Hello everyone, welcome back. And today we got a meeting problem that is reschedule meetings for maximum free time version 2. Um, but it looks like an upgrade version of the yesterday problem, but it's still a medium one. So okay, just continue. All right. You are given an integers event. Okay. Mm. That means we got an interval and it's not overlapped. um, and yeah, the meeting that occurs during the event between t equal to 0 to even time, that means this had a fixed size. You can reschedule at most one meeting by moving its start time while maintaining the same duration. It's like take the segment, the interval, and move somewhere else. Remember, it's not overlaps another events, right? uh, and we need to maximize longest continuous periods of free time. Free time like this, you can see the white space here. Okay, return the maximum amount of free time possible after rearrange it. Okay, that means we can take a interval and put this anywhere in the free time in the remaining space. Um, okay, if it's valid for the relative ordering of the meetings to change after rescheduling one meetings. That's when you're not just only moving around uh, the space is state, but you can put it to anywhere. For example, the you can see the 9 to 10 here, you can put it to 1 2, right? Just like that. Okay, but that took the example 3 here. At the beginning, you got the maximum free time is 1 2 3 3. Okay, and after reschedule, I'm gonna move these 3 to 4 here to 8 to 9, and you got this a continuous free time from 1 2 3 4 5 6. That means you got 6, 6 free time. I think so, 3 days. All right. There's no time during the evening. Mm. So okay. For this problem, I think after read the problem, we got a straightforward solution. Um, all right, let's try. You got a segment, and you got some interval here. Maybe you got some interval here. And for example, for one segment, you can move it to, for example, for to this, like to this, okay, to this is okay, and to this is okay too. But the most straightforward ways in that is you can try on the possible gap between the segment. Let me extend this. I mean, okay, let me extend this. For example, you got it. And for even for if you want to move one event, you can move it to any gap. For example, this is the one gap. You can move to this gap, move to this gap, move to this gap. As well, you can move around this gap too. And you know, yeah, you can try on the way. But first of all, let's take this into consideration. If you got like you got this one, the second, for example, and you want to like you move this to somewhere between this gap, what is the best position? You can not put here. Why? Because it's divided the original free time here into uh, two segment with smaller size, and we got one thing. This side is fixes, right? Fixes, and the side of the event we want to move it fixes to. What does that mean? That means the remaining free time here not change. Even you put it here or put it here or you put it here, the sum of the remaining time is your step. But to make it continuously maximum to maximize continuously, I mean, to maximize the continuous space, we need to put this. Now let me change color. Need to put it here. So if here you got this remaining space, this remaining spaces, is equal to sum of this one and this one, but it's continuous. Okay, or you can put here too, wherever. But remember, the length still the same. The one we need to focus is to make it continuous by putting it on the left or on the right here. Okay, that's the first point. That means you can push it here, you can push it here, push it here, like you can push it here, or the beginning is okay too. The 2 points we need to consider here, for example, you got for example, you got change color, um, you got some segment, like this one, you got this way, you got this segment of this way. For example, you got this another segment of this way. Oh, and you got a segment with this length. Okay, so when you can move, you cannot move to the gap of this segment because the space is not enough. Okay, so we ignore this, right? It's obviously we can move to the space that have the remaining length is less than the size of the interval we want to move, and but you can see you can put it here or here too because it's fixed. Okay, it's the size of the length here is largest or equal to the length of this segment. But which one we need to put to shape to keep the maximum, to find the maximum read time. If you put there, it maybe cost you this one, maybe it's cost you this. But if you put there, it may cost you this, and you got some remaining space here. But you can only choose one. And there's obviously like if you choose this, you can say the original length of the second one here, right? But if you choose this, you can say this one, you can say this, and a little bit this. But we got the maximum, which is largest. Obviously, the first one. That means the first solution that is to put the segment interval in the smaller length to keep the largest length. This I want to keep this, so I want to put this. It's obviously because I explained before. So the solution here is try for each interval. You can, if you can put this. Wait a minute. For this one, we got a conclusion. This is the original length of the free space, and for example, the h is the length of the segment with the interval want to put in, and we got the it's like the pre-time. You got this pre-time. So now we don't even care about the position of it. We just only care about the length and the f here. If you choose to push in some space like this, is it L? It's gonna be L minus h by on way. I the L2 is the L3 minus h. If you choose to push the interval in the segment, and for on the other gap, on the other length, it stays the same. So there's only one segment that affected by putting the segment into the interval into the gap. And the best way is to choose the most suitable, the most fixed. That means it's not small. The gap is not smaller, but it's like just fit, right fit. That means the smallest one that's largest or equal to the length of the interval want to put in, and choose this, sacrifice it to say the best. Okay, to say the best. Okay, this mass. You don't want to put the segment here and reduce the length of this to this. While this is still smaller than keep this one, right? I hope you understand what I say. But now let's dive into the implementation. Now the problem turns out we need to calculate the gap between on two continuous segments, and for and try each segment to put somewhere, right? And how to put somewhere is that just to find the segment, the just write fixed segment and put it on. Then then the answers is the mask segment we remaining. Okay, all right. Let's trace some it's like the next thing for this for I'm gonna do stop time sign sign I plus one and like it's push back. Gonna do far from what was um remember if slide and equal to one, so it's gonna be what? I know. Mm, no, forgot about it. Got the end time of I minus start time. Oh no 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 no. Start time of I minus end time minus one. For example, you got three minus two is one. You got one gap here. All right. Um, to in order to find the smallest one, you binary search and short this but there's one thing we need to remember. That's the in the scale. You can see, uh, beside putting it in somewhere some gap else, you can also adjust this element into its gap, and the length is unchanged. The length is unchanged. um, if you fix this, the length unchanged, but you move out, the length of this increase, h, increase x. The fewest I increase h. If you successfully put it somewhere else, so remember to check this one. Okay. All right. So I'm gonna use answers here, and for a gap here, you can rearrange. It's like you could rearrange it so we can get the gap. This. No, sorry. But what happens if this is the only one that fits this one? If I want to got this segment, it only fit this one, and you're gonna not find something else, and you cannot move this. So check if you could find a segment. If you find it, so it might be the gap. The gap. I got something that's like you cannot the gap from here. You cannot put it to this gap. You cannot put it to this gap too. It's like you can put yourself into to between the gap and the cell. That's the problem. So it's not gonna happen. I believe it's not happen. I think it's not happen. Why? Because you put this goes to the length is smaller than you don't put it. Right? You just arrange this to this, and the mask is still this. Although it's the it's look like mistake, but it's not affect our result. But if you want to do it perfectly, I gonna ignore this case. That means ignore. It's like if we search and we found an index, it's like the I index here. I gonna ignore it. Uh, Gap this. I find the index of this the I plus one. This is I. I gonna ignore the index I and I plus one. Right? I gonna ignore this. Okay. So we need to store the index of this one. But actually we don't need to do so. That means we think. Still need to do so. Slide and define space. Still trying to run this. put this somewhere else. Put this mask hyper. Wait a minute. Okay, I think it's okay. I'm gonna implement this without considering if we need to consider it. Yeah, of course we need to consider it. I think we need to consider it. Next, index I is the I. I'm gonna short the index here. Oh no, we need to short start previous. Remember to push the the start time 0, and don't forget to put the event time, and that's the end time end back. Okay, back the remaining space. All right. So we got n plus 1 segment. But how can we do this? Just give me a second. Shortest x. Wait, we got this one. We got the second one. Actually, we can use a set here, but it's just over engineer. Very short. I don't. Yeah, actually, I don't. Just binary search position. But actually, we need to binary search. Actually, you don't need to do so. If there are two elements, we can, for example, you got too much element here, and then you can put it in. So that does not affect this. But you, if you put it this, it's still not affected. So we only care about two. This one, this two. Okay, I can see. I can see. It's not affect for sure. It not affect. Um, no, it's affect because we need to check if we can move out. That's maybe not consider this segment and this segment. Let's say I and I plus one. For example, this is if you remove this, you must not consider this segment and this segment. As we have this one, we must not consider consider this segment and this segment. Okay, and it's okay. It's okay. Next in. So return the index of this on. Got the index here. And we need to implement it by research, um, by the research on private. Uh, in, in actually we don't need to do by research here. Yes. This finds if is while to I index pause is like I index pause. I just want to continue. But what if we only get one segment? You got one segment. So I don't know if this case. That's must be true. So now we got at least two segments. So don't care about this. While the index pose is like largest or equal to, oh my god, we can put it, but it less that's on the no the size start the size gonna like gotta ignore this, can put it. So the only ways is to now to stay in the science. The answers here is like massive answers with the now the this one minus the previous one. Six. That's how I ignore this one. And so the previous one is this I. Um, okay, wait a minute, just wait a minute. X. If the this line is this one, got this one, and time is n sign n, and event time is 0. That is and the answers minus the length of this queuing, which is this queuing segment. All right. We got this. This is the case when you move inside its gap. You got the previous the previous end time here and the next start time, and you got the gap and you minus its size. Okay, if it's close and we got as not 1, 2, 3 segments, so that ignore escape. We got at least 3 seconds. So we can got this one, this one, this one. So if you this one you can ignore the you can ignore the case if I is the I plus one. You can ignore this and this is not to this segment. You got remaining this one. And if this size larger or equal, you can put it here. And this size become if we can put it, so that means we can keep you can keep the remaining space that you put it out, it grabs to another, so got the new gap that's the side, right? But we also need to like check, check. We need to go down one more. It's like okay, the dose is 0, so we can move down. First, let's check if we could get this. No, no, we could get this right. We could get this obviously. Obviously, no. Fi we got here, and we must put there. And it's like if post is like equal to 0, so it's the only way. It's the only way. It's like this yes, post minus the cosine. Cosine here. Else like one have not changed. Still remember to check, to find the position. We need to decrease 1 to from this perspective. No, no, post this post. We should and we got the maximum one, and I gonna like I will say this. I will say this point. For example, you got this, and you must put this here. You put the segment here if its size is acceptable. So I gonna do is like pause 3, and it's like TDP pause, and do this again. I don't know if it's really complicated. Ignore. Remember, TDP pause is 0. Okay, TMP post. If TMP post is available, I gonna can move to this one. Yeah, obviously we just need to check this. See, whatever. But now if TMP post is available, this the next TMP post is acceptable. So we could take the take the post. I mean the post team post here. Done. Okay, that is. But else you got no TMP post. So because push it in the post and minus the sign here. Got it. You just got it. Okay, all right. Now we got the answers. Take a lot of time. Event time. Index. That's right. True. What true? One. You got one, two, one, two. Okay, one, two. Answer is two because you could. Okay, two. Right. And three. Oh, really? So, so hmm. You got two. Oh my God, we minus one, two. Got it. Those two. Multiples. Actually, not this. It must be this index. Why? What happened to you? Index sign is n plus one. That's true. These signs. Ah, okay, okay. No, no. Got three segment and divide two. That's mean. Oh, it's not true. So I need to print out the index here. 01. Oh, no, no, no. See, see. Nice. Just got it. Hope you understand my idea. In order to summarize, it's about try interval and put it somewhere else. The first way to move inside you. So it must be the length of the distance of the next one and the previous one minus the side your. And the second way is to find the maximum free space, and you try some other that fix your length and sacrifice this to get the maximum length as I described here. First on, if you find that location, that means you can move it out of the segment and you got the original free time. And if you find a sacrifice index, you can sacrifice this positions in order to achieve the maximum one here. Uh, and that's it. And the final solution is to put your segment into a segment. That means you need to get that at minus cosine. That's all. That's nice.